Greetings everyone, my name is Dr. P. Pavan Kumar and I am going to explain helium neon laser concept in the chapter of lasers in the course of Advanced Engineering Physics in this video. Now we'll explore that. Now come to the contents of this, we are explaining this helium neon laser that consists of introduction, construction, working, drawbacks and applications of helium neon laser we are going to discuss in this video. Now let's move to the introduction part. So helium neon laser was constructed by Ali Jawan in the year 1961. That's after the 1 year immediate ruby laser, that was the first laser. And it is an example for gas laser because the active medium is a gas. So it is taken as a gas laser. And not like ruby is a discontinuous laser, but helium neon laser is a continuous laser. A continuous wave we will get it here. And this is the 4-level laser system. And in this laser, the active medium is helium neon gas. Now we'll see in clear in the construction part. Now we'll move to the construction. In this one, first we will take a discharge tube. So this discharge tube with the discharge electrodes, and this discharge electrodes are connected to radio frequency generator. And in the discharge tube, we will take the mixture of helium neon gas at 10:1 ratio. Means for 10 helium particles, we are going to have only 1 neon particle. And this discharge tube is closed two sides. One side we are using a fully reflecting mirror. Other side we are using a partially reflecting mirror. Right. And here we will take this helium is at a pressure of 0.1 mm of Hg. That's helium pressure, and neon at 0.01 mm of Hg pressure. So that pressure should be maintained in the discharge tube. And here active medium is a helium neon at 10:1 ratio. This is a simple construction of helium neon laser. Now here, as I said, 3 parameters are important to produce any laser. Active medium, that's a helium neon gas, and the resonant cavity, the mirrors, one is fully reflecting, other one is partially reflecting mirrors, that's for the amplification purpose, and another one pumping system is a electrical discharge that acts as a pumping system for this. This is the simple construction of helium neon laser. Now we'll see the working of helium neon laser. This consists of helium consists of 3 energy levels, that's F1, F2, F3. F1 is a ground state, F2, F3 are excited states, and neon consists of 6 energy levels, that's E1 to E6. And before applying RF generator, so all helium particles are in F1 state and all neon particles are there in the E1 state. Now whenever the discharge tube start, electrons will move through this one, and electrons hit with the helium particles. By that collision, helium particles get excited to F2 and F3 states. Here F2 and F3 states are metastable states. The particles will be stayed for sufficiently long time, and when they are in this state, they will interact with the ground state neon particles and they will give energy to ground state neon particles. By taking energy from helium particles, these neon particles get excited to E4 and E6 states. Now again here E4 and E6 are metastable states. The particles will be stayed for sufficiently long time. Here more number of particles are accumulated in E4 and E6 states, and E6, E5 are under population inversion, and E4 and E3 also under population inversion. Fine. And after getting population inversion, the particles will come to E5 state, and the particles may come from E6 to E3 state, and the particle may also come from E4 to E3. All these transitions based on selection rules in quantum mechanics. And the transition from E6 to E5 emits a photon of a wavelength 3.39 micrometer, and E6 to E3 emits 6328 angstroms, and E4 to E3 emits 1.15 micrometer. So in that way, 3 photons gets released. out of three photons, only 6.3 to 8 angstroms is in the visible region. So we can stop these 3.39 and 1.15 micrometer photons by using absorbers. So only we left with 6.3 to 8 angstroms photon that will pass through the discharge tube, hit with a partially reflecting mirror. Energy is not sufficient, that comes back. While that is coming back, this stimulate one more particle in the E6 state to E3, so one will become 2 photons. And these 2 photons hit with a fully reflecting mirror in the discharge tube and again comes back. While coming back, these 2 stimulate 2 more particles in the E6 state and they become 4. Like that, multiple reflections happens in the discharge tube to get sufficient energy. And after getting sufficient energy, the laser will come out from the partially reflecting mirror with 6.3 to 8 angstroms wavelength. But here the few particles are there in E5 state, they come to E3 state by non-radiative transition. Means the particles move from E5 to E3 by emitting heat energy only. No photon will be released. Now all particles are there in E3 state. They come to E2 state by emitting a wavelength of 6000 angstroms, but that is by spontaneous emission. Now again E2 to E1 they come down by collision with the walls of a discharge tube. So while this entire process is happening, this helium get excited and they readily give the energy to the ground state neon, and helium come down and again by taking energy they move up, and the same process continues. So as this process is continuous, output laser is also continuous. Now we will see the image clearly. This is a clear energy level diagram for the helium neon laser. Now the main transitions here are E6 to E5, that is 6328 angstrom, E6 to E5, that is 3.39 micrometer, and E4 to E3, that is 1.15 micrometer, and E6 to E3, that is 6328 angstroms, and here E5 to E3 is a non-radiative transition, and they come from E3 to E2 with the 6000 angstroms, but it is a spontaneous emission, it's not useful for the laser. And again they come from E2 to E1 by the collision with the walls of a discharge tube. So out of all these things, only 6.3 to 8 angstroms is only in the visible region, so that we will use it as an output laser from the helium neon. And the major drawbacks in the helium neon laser is output power is low compared with the ruby laser, and here over a period of time mirrors will be eroded, they become weak because of the continuous collisions and because of the discharge, so mirrors will become eroded. But we have a facility, we can place it outside by placing the windows at a Brewster's angle. And the major applications of the helium neon laser is a barcode scanners and interferometry applications. And this is about the helium neon laser. And thank you very much. Happy learning. Thank you.